Hi, my name is Lizbeth, and today I'm going to be going over limiting reactants. So our goal for today is to use this equation to find the theoretical yield and the percent yield given our actual yield. So where are we going to start? First, we have to make sure that our equation is balanced. Luckily for us, it is. So that's cool. All right, so what we're going to do now is that we're going to convert from the grams of one reactant to our product, the grams of the other reactant to our product, and see which one gives us the smallest value. So let's talk first about what exactly theoretical yield is. So theoretical yield and limiting reactants, if I like to think about making a sandwich, right? So there's always something limiting you from making an infinite amount of sandwiches, right? So let's say we have 4 pieces of bread, 7 pieces of cheese, and like 8 pieces of ham or whatever, right? So how many sandwiches can you make? You can only make 2, right? Because those 4 pieces of bread are going to limit you from making any more because each sandwich has 2 pieces of bread. However, that also means that you didn't use up all of your ham and cheese. So that would be your excess reactant. Your limiting reactant in that problem would be your bread, and then your ham and cheese would be your excess reactants. And what we're trying to figure out is which one of these is going to be consumed first and limit the amount of product that you can make. So let's start. We're going to start off with the 2.5 grams of this guy right here. I believe this is salicylic acid. So 2.5 grams of C7H6O3. And we're going to convert that to moles. So this is basic stoichiometry. You're going to go from grams to moles to moles to grams. To go from grams to moles, you're going to use your molar mass. Then we're going to use our mole to mole ratio from our balanced equation. And then we're going to use the final molar mass to find the final grams of our product. So first, grams has to go on the bottom so that they can cancel. And we're going to have 1 mole of this thing up here. And I already found the molar mass before, so it's going to be 138.13. Now we're going to do a mole to mole ratio. So I'm going to go from here to here. So the moles of this guy is going to go on the bottom so that they can cancel. And the moles of this guy is going to go on the top because that's what we're heading to. And from our balanced equation, you can see that for every 1 mole of the salicylic acid, we have 1 mole of this. It's not always going to be 1-to-1, so make sure for this step to always, always, always look at your balanced equation. So now we're going to go to grams of our product. So we're going to have 1 mole of our product on the bottom. And the molar mass for that is going to be 152.16. And that's going to give us the final grams. I know it looks long, but it's totally worth it. So you're going to do the 2.5 divided by this value and then multiplied by that value, and that's going to give you 2.8 grams of our product. All right, so you might think that's going to be our theoretical yields, but we don't really know yet. We have to make sure we convert from this guy to this guy first. So we're going to start off with the 10.31 grams of that. And we're going to use basically the same process. So we're going to use the molar mass. So for every 1 mole of our reactant, we're going to have the grams of the reactant. And the molar mass for that one is 32.04. Then we're going to do a molar ratio. So moles of our reactant will go on the bottom. And then moles of our product will go on the top. So again, we're going to look at our balanced equation for this. So for every 1 mole of our reactant, we have 1 mole of our product. It's just casually that. Remember to always make sure, if there's a 2 here, it would change this to a 2. So keep that in mind. And then we're going to convert to grams. Luckily, this step is the same. So 1 mole of C8H8O3 has 152.16 grams of C8. H8O3. And that value is going to be bigger. It's going to be 49.0 grams of C8H8O3. So now that we have both of our yields from each of our reactants, we're going to see which one gives us the smaller value. So the smaller value here, as you guys can tell, is going to be the 2.8 grams of C8H8O3. So this is what we call our theoretical yield. Now, since this is our theoretical yield, we can say that this is going to be our limiting reactant. So as you can, if you think about it, right, limiting means that it doesn't allow it to proceed any further, and it's a reactant. So a lot of times we're tempted to say, oh, this is our limiting reactant, but this is our product. So since this is a product, it cannot be our limiting reactant. So our limiting reactant is what gives us our theoretical yield. Don't mess those up. So then this means this is our excess reactant. All right, so now we found our theoretical yield. Our theoretical yield was found to be 2.8 grams. Now, the next question is to find our percent yield. Our percent yield is going to be found by using an equation. So our percent yield is equal to the actual yield or experimental yield, if you learned it that way, over your theoretical yield. So unfortunately, and that's times 100. Unfortunately, we don't live in a perfect world, so when we carry out an experiment, things don't always go as planned. So our actual yield is usually quite small compared to our theoretical yield. So if you're ever confused as to which one's the actual yield versus the theoretical yield, it's going to be the smaller value. Also, the actual yield is always given to you unless you actually perform the experiment yourself. And the theoretical yield is going to come by the stoichiometry. So if you did math to get the value, that's going to be your theoretical yield. So let's go ahead and plug in those values. Our actual yield is going to be 1.27. Our theoretical yield is 2.8. And that's going to be divided by each other times 100%. And I got that to be 45%. So we made 45% of what the maximum amount that we can make was. So to recap, you're going to go from the grams of the reactant, of one of the reactants, to the grams of the product, and do it again for the second one. Find the one that gives you the smallest value. That's going to give you your theoretical yield. What gives you your theoretical yield is your limiting reactant. Whatever gives you your excess stuff is going to be your excess reactant. And to find your percent yield, it's just actual yield over theoretical yield times 100%. The actual yield can also be called the experimental yield. And that is how you find the limiting reactant, the theoretical yield, and the percent yield.